horizontal. And this is going to be what? Oh, raw count. Okay. And 0 to 1023. And then let's do our vertical. And this is going to be what? Oh, measured. Current. And this is going to be in amps. So let's give this a proper title. This is going to be the raw count correlation to the measured current. How about that? So this is what we'll use to help us with our programming and getting proper measurements out. So if I go ahead and I select this, I'm going to go ahead and add a trend line, and I'll do the same thing that I did before. And this is going to be our trend line right here. And you can see that our coefficient of determination is pretty high. And so this Y is our measured current, and then this X is our raw count. So we need to put this in order, and you see it has a negative sign there. So we need to put this in order to get the proper measurements. So let's do it. And let's see if we get the proper measurements. So the first thing I want to do is I want to go ahead and get rid of my voltage calculation and my serial print calculation. And so we'll still have our raw count. And what I want to do is I want to put the new equation in. And the new equation is going to be called, let me call it, I could just call it voltage. You know what, that's what I'll do. Equals to negative 0.0012 times raw count, okay, plus 0.6139. All right. I mean, I can always put space in between here. All right. You know what? Let me call it voltage 2, just for the sake of it, voltage 2. All right. And so let me go ahead and verify this. I want to show you guys. Oh, I want to print this out too. Show you guys a couple of errors that I'm about to make. Serial.print. And I am going to do voltage 2. Okay. So I'm going to run this program and let's see. Oh, I got some red here. So what is it saying? It's saying it says voltage 2 is not declared in this scope. Okay, it was not declared in the scope. So what they're saying is, I didn't do this. I didn't declare it. Like I didn't call a float. I didn't call it, say float voltage 2. And that's pretty much, if I run it now, or if I compile it, you'll see that that particular error goes away. Okay, and so you'll see serial print, raw count. What is it saying? It's saying it expected a semicolon before delay. Okay, so it's talking about this here. I put the semicolon here, and then I verify it. So you'll see that I'm still doing this. And so I actually didn't go down far enough, but here's another one where I need the semicolon. And if I do this, you'll see that they all go away. And so I am just going to place a little statement here. Create global variable for I'm just going to say, I should call this current. You know what I'm saying? I'm going to call that current. All right. And because that's what it is. Current. And instead of all of that, current. All right. create a global variable for current between 0 and 5 volts. There we go. So I can verify that one as well. And since I did that, I want to make sure that I comment my equation. So this equation has been generated from a regression analysis of the raw count to the measured current. How about that? That's pretty descriptive. And then right here, we are just printing the current. All right. So I'm going to go ahead and do this again, and then I'm going to send it on over to my Arduino, and I want to look at what's being printed out here. Now look at what's happening. Look at how that data is going to the right. Really weird, isn't it? Well, the reason why is because I didn't print new line, or see how this has LN. So I'm going to do that here, LN, and I'll run that back over, and then you'll see that it's going to print, and it's going to go down where we can actually read it nicely. Okay, so this is supposed to be 0. Let me put this one back on voltage. Okay, so this is supposed to be 0, and this is just my count. And as I increase my voltage over here on the side, or as I increase it, we should be able to see the actual current change here. So now realize that this reading here is for the current, okay? And remember that this equation right here is coming from right here, all right? So let's see. I'm gonna go ahead and increase my voltage. And I'm at 230, 265. And that's 265 milliamps. And so what you see here is 0.27. That is amps. So we are right on. I'm having 270 right there. Look at that, guys. Whoa, awesome. So let's go ahead and increase it a little bit more. Let's see if we can go up to maybe 400 here. All right. So 395, getting like 0.4 right here. Wonder how could I get more decimal places in here? Oh, okay. So it has float. I wonder if I made this a double, what would that do? All right. So I'm gonna run that again and see if it'll give me more decimal places. No, it ain't give me no more decimal places. But any two ways, I'm gonna go back to float. I think that's 172. Oh, that's fine. All right. So it's at 405 milliamps, and I'm getting 4.5 here. For this system, it's reading just fine. You know, it's supposedly calibrated according to this system, and hey, that's totally fine for me. And again, we're not supposed to go beyond 600, as you could see. Wait a minute, it's reading above 600 though. But you see how it stops here at 610? I mean, it's 0.61. So we have a limit on how far up we could read, okay? So that's fine. We at least know that. The resolution is quite high on well, I say it's quite high, but it's milliamps. So okay, that's it for that particular calibration. So I'll stop this, and When we come back, we're going to work to calibrate the magnetic field sensor with the current probe. Okay, have a setup for that.